We're very happy to have you here and to talk about this great music heritage project. I was involved in this project as a communication officer, and I'm also involved with Europeana Tech as a community manager. And today we're happy to host some speakers of this project. I'm giving the floor to Peter first, and he will give an overview of this project. It's a pretty complex project, very ambitious as well, lots of pilots. So Peter will give you some overview to have a better idea of what this project was all about. Peter, the floor is yours.
Yeah, thank you. So yes, I'm jumping in for Andreas Scharnhorst, who unfortunately fell ill, and I was a pilot leader in the project, but I now will try to give a broad overview to give you an idea of what we did and what were the aims of the project. And I like to start with the text as is on the website of the project, and this is still the shortest and adequate summary of what we did that is findable. So let's see what are the keywords here. So the project run over 3 years, last 3 years, to recreate the connections between music, people, places, and events from the 16th century to the modern day. So it's about music heritage. And these findings will be available, or are available right now. So this, of course, it is text from the earlier in the project, but these findings are available to everyone as an interconnected global database on the web, a knowledge graph, and that will enhance our understanding of European musical heritage. So we recreate connections, and we present that we store that in a knowledge graph. Why did we do that? The ambition of the project was to find ways to support music scholars and cultural institutions to deal with musical cultural heritage. And the question we ask is what are the gaps? So what is not available in concerning computational methods that is crucial for both scholars and cultural institutions to work with digitized cultural heritage? And then, well, that's of course a very broad question. Therefore, in the project we had 10 pilot projects with a very diverse nature that each designs solutions to specific problems, but in a way that is transferable and reproducible for more general classes of problems. So what are these gaps that we addressed in the project? First of all, before the project, we did analysis of the field, and it was evident that musical heritage knowledge is scarcely available in machine-readable digital format on the web as open data. It is distributed and heterogeneous, so there are data sets, but these are isolated, disconnected, and also quite some music heritage data is non-existent in digital form, or it exists in a poor way. Another gap that we addressed is the managing and analyzing of large collections of data. So both for scholars and for cultural institutions, this is a crucial aim, especially scholars in the humanities like musicologists and music theorists. They do not have a tradition of dealing with large data sets, so therefore we need ways to support them. And the third thing we addressed is the lack of effective interaction, and interaction that's both with accessibility for general public, but also accessibility of this data for music experts. So we solve this by designing ontologies and knowledge graphs to represent this data as linked open data, and by designing the knowledge extraction and music analysis methods, and by designing tools for and interface components for experiencing music and music heritage. And these tools were designed in a co-design fashion, so the demands and the needs of the end users were leading from the onset of the project. And this guaranteed that the interface components we designed are indeed usable for music experts and general public. So this is an overview of the 10 pilot projects. There's no time to go to address them all now, but it is as diverse as musical instruments, music theory, music history of a city, Bologna in this case, music of interaction interface components, interlinking data sets, search engines for music, etc. So that was a very broad sample of projects. And the project was organized in work packages, and the main work packages on the contents were about knowledge graphs, music patterns, knowledge extractions from text, and human interaction, so human-computer interaction. And so this forms the let's say the structure of the work in the project. Then what resulted is an ecosystem of what we called components, and we have over 100 components, which are software libraries or interface components or data sets or ontologies, knowledge graphs, etc. And this ecosystem consists of reusable components that can be generalized for wider purposes, and it can be explored through the online. The link is at the bottom of this page. A metadata structure is built around it so that it can be easily explored, and all the connections between the components can be are visible in there. So please have a visit to that to see the wide range of what we did in the project. It's impossible for me to give even the tip of the iceberg in these 5 minutes. One thing I want to highlight is the Polifonia ontology network, which is an ontology for representing data. It's musical data. It combines and it links to previous existing ontologies. It harmonizes those. And in the end, we have a very comprehensive set of classes to represent musical knowledge, divided into musical sources, instruments, metadata about music entities, and music representation, including music notation or representation of music patterns in music. So yeah, here I put a link as well at the bottom of the slide, so you can explore this ontology online. Yeah, as I said, there are numerous outputs. So I just let this scroll a bit. Software libraries for folk songs, for other kinds of music, harmony data sets, interface components. There are knowledge graphs for instruments, bells, and organs, which we will address later in this webinar, etc. Harmony, Roman chords, music meta, and then there are data sets. And again, please visit the website to explore all of this. And I think here I end my quick introduction. I hope you have now a bit of an overview of what we did and what the connecting themes were. So thank you.
I think that I can jump in.
Yes.
Yes. Hi, everybody. My name is Giulia Renda. I am a PhD student at the University of Bologna, and I was part of the development team that work on the Polifonia web portal, and that's basically why I'm here today for this talk. I won't share a slide with you. I have them prepared. If you want, I can send it to you afterwards. But what I want to do is to directly show you the web portal. and guide you through its exploration. And while I'm at it, I will explain you a few technicalities. So here we are. What you see is the home page of the web portal. That is the place where all the Polifonia datasets come together to offer cross-dataset information that would not be accessible otherwise. This is possible thanks to an alignment and reconciliation process among our datasets, our internal dataset, but also external ones, third-party authorities, let's say, such as Wikidata, DBpedia, VIAF, and so on. The portal is designed with a novel methodology that was one of the output that we published as a team. This novel methodology combines ontology requirements and user design approaches to accommodate both data requirements but also user requirements. It facilitates serendipitous discovery through user journeys, as we will see, of incremental difficulty, making the portal appealing both for general users, that is the main target of our portal, but also to experts. So what we see here from the home page immediately are, we can notice a few aspects. First of all, you can notice these categories. We will get back to them in a little bit, but also the user is able to understand immediately which type of action she can perform here. She can explore content, search, play with it, but also discover external outputs that are not inside the web portal, but were produced by the Polifonia consortium. For example, we have the Muso catalog, we have a linguistic corpus, there is the possibility to create a data story with melody, and so on. I've anticipated to you that the methodology that we use to develop the web portal facilitates serendipitous discovery. What we mean is that we decided to apply a follow your nose type of exploration to accompany the user. As you can see, let me turn on the music. The user can start exploring the web portal simply by scrolling down. We have text that introduces the content of the web portal, and you can hear, I hope, the melody. What the user find are some highlights. These highlights are, first of all, an example that we propose to the user of a story that we can tell with data. You see Manchester, Joy Division, punk rock, electric guitar, and Love Will Tear Us Apart. For those of you that knows a little bit about Joy Division, you can understand that all these entities are connected together. But at the same time, they represent topics, categories that we consider to be important for the user to play with. And you see at the very top of the web portal, are always there and can be used and can help the user in the exploration of the content. We decided on these categories based on user surveys that we have carried out and are a way for us to extract all the information that could appeal to the user and that is contained in all the datasets output of Polifonia. The user can decide to click on one of these highlights or, for example, select the artist category. What happens is that the user is redirected to the artist section. What you can see here is that we have, as we expected, the Joy Division. Here, data curators decided on an example from which the user can start with. We have the name, we have a column with results that in some way are connected to the entity Joy Division. And we have an explanation of why we are seeing these results. For example, Interpol was influenced by Joy Division. That is the reason why we are seeing this. I can open filter, and these are particularly helpful because can help the user to understand which type of results are being shown. For example, if I check the filters for relation and I want to discover more what is that as Joy Division as subject, I find one result that is the Manchester Digital Music Archive. You see that if I hover it, there are highlights that suggest the user, that guides the user on where she can click. If I want to know more about this archive, I can click on the plus button, and a card will open with additional information about this digital archive that is contained, I can tell you, in Muso, and we have external links where I can understand and know more about this specific archive. Let's say, though, that the user is not interested at all in Joy Division. What the user can do is search in all the artists available in Polifonia. For example, I can search for Charlie Chaplin, and you see that information changes accordingly. What is happening here is that this search actually is performed on a link set that we have created, and it's the only data that we store. This link set is composed of Polifonia entities. In this case, I search for the Charlie Chaplin Polifonia entity. This Polifonia entity has been, thanks to a process that we designed, has been reconciled, aligned to all the Charlie Chaplin available in all the datasets that are present in this web portal. Meaning that the information that I see here, in this case, I can check this small bar chart for the source. This information comes from the Meetup dataset, from Wikidata, and the Sound and Vision dataset. This is why this is how we are able to show cross dataset information. If I open the card of Charlie Chaplin, because I want to know more about him, first of all, you can notice that this card is different from the one from the previous one that I showed you, because cards are tailored on the type of entity we are seeing. In this case, we have an artist card. This means that information that we show is tailored and curated on the type of entities. In this case, we have biography for the artist coming from the Meetup dataset, but we also see that we have the possibility to see another one, a Wikidata biography. We have an image. We have relations to places. All these relations are actually links that will lead you, if I click on Chicago, for example, will open the place card for Chicago, and different type of information will be shown. I can explore all the persons that Charlie Chaplin had a sort of interaction with. Again, in this case, information data coming from meetups. I can check the concert he participated in, thanks to the Sound and Vision dataset, but also check, and this again was possible thanks to the reconciliation process, its external page in Discogs, because we were able, when possible, to connect them. So all the actions that I've shown you can be repeated for all these categories. For example, if I go to genre, I have as a starting point punk rock. You see that information comes from yet different datasets. In this case, for example, I have a one that you have not seen yet, that is the red one. If I open the punk rock card, yet again, you see it changes and different type of information is shown. I think that I would like to stop here because I've shown you more or less everything, and I hope you have questions. This is the menu, just a last bit of information where you find everything, the project, especially here, you can see, for example, the data sets that are at the moment included. Information data that we have is very different because comes from different sources. So we have data about artists, genres, instrument places, but also very specific instruments, as probably Peter will explain to you, such as organs, bells, as you will see with Elena later. So yeah, please ask questions. Okay, I don't know, Marlos, how we want to manage this. I can I read the questions from the chat. I don't know if participants can speak, but yeah, I see. I can start in the meantime. I see there is a way for users to browse the available genres so they know what they can search by. No. The simple answer is no, but if you let me show you, for example, you start to type, you have suggestions and you can scroll down on suggestions. So that's a possibility, for example. How did you choose focus and content areas? I asked you to be maybe more specific in the question because I am not too sure on how
I can use my microphone.
yeah,
Can you
if
hear
you
me?
want, please. Yeah, I can hear you.
It's a
Thank you.
fascinating project. Thank you so much. It's you're covering a huge area, you know, jazz, classical, and all kinds of popular. So how did you decide on which which areas to pursue? You know, I mean, you could conceivably do all of this just on opera and you'd have a huge task at hand. So I'm trying to understand what were the guiding principles for your work. Thank you so much.
Sure. I can start tackling it, but it's a very complicated process that was carried out since the very beginning of the research on how it could be possible to show this type of information to a general type of user. I don't know, and here I ask Marno, Andrea, if our deliverables, for example, are public yet, because there we have a lot of information about this, on how we carried out research on competitors, first of all, but also how we yet again designed our methodology that, by the way, I have the link here for yeah, I can share with you one of the papers that we have published about it that explains how we were able to integrate what the data that we had at hand could offer with usability requirements. That was, I mean, at least at the best of our knowledge, nothing like this was attempted before, at least not successfully. So we needed an ad hoc methodology to understand which were the important data and which were the possible exploratory paths that users could follow in the exploration of the content. This methodology not only allowed us to develop on a design level the web portal, it also allows us to understand which were users' necessities. And thanks to that, we understood that we had to develop 4 different platforms with 4 different user targets, 3 plus one software for different purposes. I've mentioned Muso and Melody are the output of this methodology as well. As for the information, the data that we show physically right now in the web portal, there is a process of data curation, meaning that we talked with the data expert of each pilot, of each data set, and they, based on the categories that we have predefined, they were able to tell us, okay, we have coming from this data set, we have this information that is important that we can show. So these are the SPARQL queries necessary to retrieve this information. And in this sense, the data that we show is curated. I hope that answered the question. Probably it was too long on my part, sorry.
No, thank you so much. And I'm looking forward to looking at the papers.
Okay. I don't know if I still have time to answer question, Marlos. I didn't actually check the time.
Maybe 2 more minutes, but then we need to move on.
Okay. Would be nice to connect to where I can find. Okay, yes. Where I can find the URIs for Charlie Chaplin or Joy Division. Every card, I mean, this is a little bit tacky, but every card has a URL. That's why we can share it. And there, for example, you can find the URI of Sound and Vision for punk rock. But it's not, since it's the web portal is not meant for experts. I mean, the general user doesn't know anything about semantic web. It's not the kind of information that we decided to make available. I would be interested to hear more about link sets, how they are created, the SIP, etc. Thanks. I don't have enough time to go into that. There is a process very quickly that searches internally in our data sets which are the alignment already existent. For example, if NIS dataset already has an alignment for Wikidata, and we use this third party to, thanks to some transitivity approaches, to connect two entities to the third one. And the link set is simply a collection of all these links. How we created the knowledge graphs and ontology. I will leave these questions. I did not participate in the creation of the Polifonia knowledge graph. I don't know if Andrea would like to speak about it, but it's a very big and complex topic that I don't think it's in today's talk at all. I think that I will stop here because otherwise I will get too much time.
Yes, thank you. We tried to pick up on remaining questions inside the chat.
Yes, yes, of course.
Other speakers can also maybe help answering some questions, that would be great. I think we need to move on to the next speaker, which is Alba. She will cover the meetups pilot. Well, the floor is yours, Alba.
Thank you very much, Marlos. Hello, everybody. I don't know if you can see my slides now. Yeah, good. Okay. So welcome, everybody. Thank you very much, Julia, Marlos, everybody at Europeana for organizing this talk. My name is Alba Morales. I'm research associate at the Open University, KMI. And I'm going to talk about the Meetups pilot, which is one of the 11 pilots that we developed during the Polifonia project. As the title says, it's related to people and music and exploring their encounters over the time. So I will start by telling you a bit about the background of the project. So the idea was like came from a necessity from researchers, scholars, and people involved in the music historical research domain. They wanted to study how people were influenced by, I don't know, meeting other people in different places, in different times, what kind of influences they have. So the idea was to help researchers and people involved in this history domain to leverage the study of this culture and social exchange. And the way to do that was to explore these musical encounters. But during this, for people that does historical research, they find sometimes that they rely heavily on information that is contained on data sources such as biographies, memoirs, books. And when they do that, they have a few problems and things that arise when they're doing that. So for example, first of all, because of the type of the resources that they have a large amount of data that come from different places, that are heterogeneous, and this makes sometimes be really difficult, complex, it's an intensive task to find these historical encounters in these documentary sources. Also, for them in order to build these kind of storylines where you can see who interacted with whom, where, in what period. It's very difficult for them to build a comprehensive storylines. And we also need other type of information. So for example, we need spatial information, geographical information. We need also temporal information, when these things happen, and also why these things happen. So this is very important for researchers. So this is how the Meetups pilot started. So the Meetups pilot enables the exploration and visualization of encounters between notable people in music. Before, there were like scattered sources built for general purposes in domains different than music history. And now with the Meetups tools and different outputs, we have evidence of historical interaction extracted from textual sources, particularly biographies. And at the end, as an output, we have a web interface that facilitates the visualization of meetups and their constituent elements, such as participants, location, time index information, and thematic annotation. So at the end, if I have enough time, you will see during the demo that you will experience how these encounters can be explored in a timeline, in a map interface, and reveal connections and relationships between music personalities. So I'm going to tell you in a very general context what was the Meetups pilot approach. So we took we follow a knowledge engineering approach. We use semantic web tools and technologies, and we focus on extracting knowledge from textual sources. So we started by collecting knowledge requirements. We built a set of stories that describe people, their requirements, what they expect to see when they are like trying to explore this kind of meetups and encounters. And then with this information, what we did was to abstract or represent what a historical meetup is in a formal way. And in this case, we use ontologies and the meetups ontology. And once we had this formal representation, we use it as a framework to build and structure data source of historical meetups, in this case, the musical meetups knowledge graph. All this information is contained in the ecosystem, and I think Marlos is sharing all this information in the chat. So very briefly, because time is key here, we started by developing the meetups ontology, where we defined what is a historical meetup. So a historical meetup basically describes encounters, for instance, collaboration and exchanges between personalities in the European history. Researchers told us that they were interested mainly on having evidence about a meetup, in this case, textual evidence, knowing who participated, where these things happened. They also wanted to know when these encounters happened. And in the end, also, they wanted to know the purpose of this meetup. So all this reflected in the meetups ontology. And then for the second, the next step in our pilot was to start collecting these data sources. We have textual resources, biographies from Wikipedia, and started to extract the different elements that are part of the meetups. In this case, we identified 4 things: people, places, temporal expressions, and themes. And based on that, we developed a hybrid knowledge extraction pipeline to identify all these elements. And that include different technologies, and also, for example, from machine learning to LLMs, and I'll explain to you a bit about this in the following slides. So as I said, we built this hybrid pipeline to recognize and link the entities that are part of the historical meetup. We started by the data collection. We collected around 33,000 biographies in text format from Wikipedia. And then on the second step, on the entity recognition, we use tools like the Wikipedia Spotlight to automatically annotate and annotate mentions of entities such as places and people, and we link these resources to these entities to the Wikipedia resources. The next thing was to identify temporal expressions. We used software for that, specifically Python libraries and tagger, like temporal expression taggers. And the idea was to find these entities, these mentions in text. So you have an example here that mentions that Edward Elgar, a famous composer, visited Paris in a specific year, and he met someone there. So after these two steps, you will see that we had this kind of data now collected separately. We have participants, locations, time expressions. Now with time expressions, the thing is, like, if we wanted to explore this information, we said, okay, we need to have this information in a specific format. So we normalize this data in a specific ISO format using, again, Python libraries. We managed to extract 65% of these temporal expressions and normalize them, and 35% corresponded to other expressions such as this next 7 years on the 20th century, and that were really difficult to normalize. So here we included in our pipeline the LLMs, large language models, so to help us to parse this information into something that we can use. So as an input, we had the context, the temporal expression, the context where this temporal expression was found, and also the name of the biography where we found this. And we built a prompt, and as an output, we had a date in ISO format. Yeah, so it was wonderful using LLMs. It helped us to parse at least 50% of these temporal expressions that were difficult before. And then in the next step, we started, continue with the entity recognition phase, where we identified the meetup themes. What were the categories? What were the types of encounters that they have? Thanks to collaboration with experts, they told us, like, what were the classes that we're more interested on. In this case, business and career, personal life, coincidence, education, public celebration, and music making. So at the beginning, in our pipeline, we use a machine learning approach. So we use a semi-supervisor classification process to build a training data set. And then we build this to classify a piece of sentence, a piece of text according to the different classes that we collected. We annotated each sentence in the corpus and assigned one of these. But then LLMs came into place. So we decided to play a little bit with them. And yeah, we did a zero-shot learning approach to identify the themes, where as an input, we had the text to analyze, and we also gave to the LLM the classes that we wanted to use. And as an output, we said, we asked the LLM to give us, like, the classification and the two most related themes according to that text that we gave to the LLM. And then we compared this information, these results, with the machine learning approach. The results were really good. As you can see here, we improved the identification of the classes, and we had a 85% accuracy in that case, which is, precision in that case, which is really good in those cases. Finally, the last two steps in our pipeline was the harmonization, where, as you know, sometimes in text, we don't have explicit mentions, but we have, like, implicit mentions, like he, she, things like that. So we included a reference task process to identify these mentions. And then finally, we identify the historical meetups, where we take a piece of text and then we check that they have all the elements that are part of the historical meetups, or if there are other texts before or after that form one meetup. But we also decided to include pieces of text that didn't have all the elements, because for researchers, sometimes it was interesting to know that a person was there, even though they didn't know when. And we call these historical traces that are also available in the demo. The last step was the construction of the knowledge graph. We use Sparkle Anything, and as you can see here, we have some statistics about that. In the example, you will find that at the end, the depth of data that we find in the knowledge graph is like the participant, a piece of text, the evidence, who participated, when happened, when this thing happened, and the theme of the encounter. So here we have an example of Edward meeting Adolf Politzer for musical training in London. So yeah. Also, if you are more curious about how we validated or evaluated of knowledge extraction pipeline, please feel free to or let us know if you have any question. We also have published these in 2 papers, so there are more details there. And now I'm going to go to the demo. I don't know if I have enough time to play with it a little bit. But before that, I just want to say, I wanted to put some faces on this team, the Meetups team here. And thank you very much. I think Marlos shared with you a lot of links and things where you can find all this information. So let me see if I can share. Can you see my screen? Yeah. Okay. So this is the
we see,
meetup.
Alba, sorry, we still see the thank yous last slide.
Okay. Let me share again. Okay. Good. Yeah. So
yes,
the Meetups web interface, thank you. You will find general information, ways to access the data, because all of this is published in a Sparkle endpoint. And the first option, it's like here we have a list of biographies that we extracted. You will find some featured biographies, but we also have a search site where you can search any kind of biographies that we contain at the moment in the knowledge graph. But there's also a way to find meetups. So I will go quickly through one biography. I don't know if we have time, Marlos, but let me show you some kind of some information that we have. At the top, you will find some top locations of this person, for example, Benjamin Britten, where he was in the United Kingdom, his top connections, the people he interacted with, the active periods, and the top type of themes that he had. The data view will have like basic information about all the kind of meetups. But the reading view is more useful, maybe, where you will find the evidence, a piece of text, and details about this meetup. In green, usually the historical meetups, and in yellow, the ones that I called historical traces, that we called historical traces, that are, let's say, incomplete. We also have a map where you can see there the meetups are located in the map, and the timeline, which is a really nice interface where we will find all the meetups categorized by the themes, and also in the end, a meetup frequency where you can see which were the most active periods of this person, and finally the participants were, if this person interacted with another musician and it's in the meetups knowledge graph, you will find them here, and then you can explore their meetups with other people. So for now, and in honor the time, I will stop here. And if you have any question, please, I'll be happy to answer them. So I'm gonna check, as Julia, I'm gonna check the chat. But if you want to jump in and just open your mic.
I think if we look at the time, we can answer the question by Angelo, and then we need to move on to the next presentation.
Okay, so what was in your experience the most challenging entity to extract? To be honest, the most challenging part was to working with DBpedia. At the beginning, we decided to work with DBpedia, but we found a lot of problems in terms of data curation, and so things like musicians, like sometimes places identified like musicians, or like these kind of things that are not easy to fix. that come from DBpedia in general. So we had to implement some curation, like validating with Wikidata, for example. These kind of things were challenging at the beginning in terms of data curation. Thank you for your question. Yeah, so I'll pass to Peter, I think, who's going to talk about organs, right?
Yes, thank you. Let me share my screen. Here it is, I hope. Yeah, so I will tell something about organs pilot, and this is what it is about. Pipe organs, often large musical instruments with long and complex histories, sometimes spanning centuries. And many of those are still in use and still being adapted. And so because of these organs are cultural heritage objects, we need documentation about them, who built them, who did work on them, who maintained them, what were the changes over time. And for the Dutch heritage, there is a paperwork, as it's called an organ encyclopedia, which was published between 1999 and 2010, 2015, I guess. So it contains descriptions of pipe organs in the Netherlands, 2,000 of them. And it contains histories and technical details and etc. So this exists on paper, and we still had the documents that went to the printer at that time. So in this pilot project, we extracted all the knowledge from that, all the information about the organs, and we built a knowledge graph representing this knowledge, which is important for organ builders, for organ advisors, and also for organ enthusiasts, for the general public. So kinds of data that were extracted is, of course, identification of the instrument, the history. Here's an example at the right side in this slide of the history. So this is about an organ in Zierikzee, and apparently in 1874 there were some changes by organ builder Witte. The organ was renovated, the front pipes were newly created, the reeds were renewed, etc. And then in 1895 there was another change at the organ by organ builder Van Dam and Sons, etc. So for each organ we have this history, but also stop lists, which is an overview of the timbres, the sounds that are available on the organ. And these also change over time. And also technical information about the pitch, wind pressure, the location of the console, etc. Which we all extracted from the encyclopedia in, well, in this case, in JSON-like structures. Yeah, so that has now been finished. All the data has been extracted and stored in this knowledge graph, and it's now maintained by the National Institute of Organ Art, which is the same institute that published the Organ Encyclopedia. They want to do a manual correction of all the data. So it's like, let's say, I guess like 95% correct or so, but they're really fond of going over everything. That's why we not have give much publicity right now. That will take maybe 1.5 years, and then it will be fully released to the public. But so there, of course, there are not only organs in the Netherlands. There are several databases, open access databases with information about organs throughout Europe. So within the context of this pilot, I also included those. So now we have an interconnected knowledge graph of around 25,000 organs all over mainly Western Europe, Germany, France, Italy, Switzerland, Austria. These are the main countries. And these are connected by the builders and also by the locations, of course. One thing I want to highlight is the ontology, and there was this question in the chat: how did we design the ontology? And well, this again is a moment to answer that. So we started, and we did that for all the pilot projects, so not only organs, but all the pilot projects. We started with designing or constructing a list of competency questions, which was in iterative way established to have the questions that the knowledge graph and ontology should answer. And for the organs pilot, we ended up with like 62 of those. This is the beginning of the list. Questions like which organ are in a certain city, which organ are near geographic location X, Y, which organs have playing at X, which organs have more than 10 stops, etc. So all this was the way to validate the ontologies and the data. And also this ontology was created in an iterative way. So I, with my knowledge of organs, sat down with the ontology designers from the team in Bologna, and then we iteratively created this ontology, which it looks maybe a bit overwhelming, but the core idea is that the organ object is connected to, at the one side, to projects, which contain the history and everything that happens in, around, and with the organ. For example, a concert or a change or deconstruction of the organ, maybe. And at the other end, organ object is connected with the parthood object, which describes the part of the organ. And the main idea here is that each part can have multiple time intervals and locations. So even if the same part is reused in another organ, that can be reflected by having another time interval location object for the same part and then connecting it to different organs. So this is a very flexible way of representing the construction and also the parts of the organs and everything that happens with and around the instruments. So yeah, and we made available a series of Sparkle queries to create this the knowledge graph from these structured input files, in this case these JSON files. Another thing I want to highlight is an interface we built for this knowledge graph. And the main idea of this is that given the overwhelming amount of data, it makes sense to, as a user, to explore what we call a path through the knowledge graph. And that can be a path connecting several organs, maybe organs by the same builder or organs at the same location. And these paths can be saved and shared with others. So it can be used privately by an organ advisor for preparation of a restoration project, for example, but it can also be shared. So instead of writing a book about all the organs of KVK in the Netherlands, we can publish a path with all the organs of this builder in the Netherlands and then share that with the general public. Let me show quickly an example of such a path. It's if you open the interface, this is what you will see in a picture of the organ. This is the first stage in the path. And here, this can be unfolded. There's the build history of the organ, all the changes that happened. Well, this is an organ in Alkmaar, by the way. And this path is about organs in Alkmaar.
Sorry to interrupt, Peter, but we are not seeing the web page.
Then thank you. I shared only the window. So now you should be able to see it.
Yes.
Right? Yeah. Okay. Yeah. So again, this is the first stage in this path. It has the build history of the organ, dispositions. And this was a key requirement from the organ experts. There are different dispositions of this organ, and by having them side by side, you can compare. So this was, for example, the disposition of this organ in 1885, and this in 1774. And there are changes. For example, in 1885, there was a prestand which was not present in 7074. So apparently something changed there. And then you can continue to the next stage, which is a question. So one stage of a path can be a question to the visitor of the path, and then I can give my answer and store that. Then next stage is another organ, and yet another organ, and well, in this way we can explore and create paths through the knowledge graph. Okay, now I guess I have to do this exercise again. Where is it this? I hope this is the right. Do you see my slide again? No.
No, not yet.
Here it is. Okay, sorry. There we go.
Yes.
Yeah. So yeah, to summarize, we now have a digitized structure that allows organ advisors and organ builders to quickly generate overviews comparing organs. We included organs throughout Western Europe in this knowledge graph, and with many links between the instruments. And well, it's also possible for organ enthusiasts to use this to construct paths themselves and to explore the data. And here are, to close, some organs because, well, they are nice, so why not show a few more? And that ends my talk. Thank you.
I see no questions in the chat now, so I think it's best to just move on to the next presentation.
Okay.
Seeing the time. So Elena, go ahead.
Thanks a lot. So good afternoon, everybody. I am Elena Musumefi and I work for the Italian Ministry of Culture. And I will briefly present the pilot that the ICCD, the Central Institute for Cataloging and Documentation of the Ministry, has been working on in the framework of Polifonia project. And next, please. The pilot belts has been focused on historical belts heritage, as this topic involves multiple dimensions connecting tangible and intangible entities, geographic and more generally spatial aspects, and other topics of interest. And more specifically, next please. We wanted to test how the general catalog of cultural heritage, which is the cataloging database, which has also this interface managed by the ICCD, could contribute to the understanding of this phenomenon, and how we could enlighten in the digital environment the relations between all these different entities. So, following our institutional task, the research was intended to provide useful tools for various purposes, such as preservation, promotion, research, or general consultation. And to make a first assessment of the database, we noticed that all the belts that we already had in the database, with no exceptions, were described as artistic property. So there was no specific distinction in the description between the museum exhibited belts and belts in use, and there was almost no data that could quickly enlighten the relations with the buildings in which the belts were located, and with the other belts which were part of the same set of belts. And there was a complete absence of any information related to the acoustic and to the musical dimensions of the belts. So we began addressing these issues in different steps. Next, please. And the first step was to create stories to highlight the needs we had in relation to the research and extracting competency questions. And in our case, for example, it was very relevant to get information on belts, but also on the architectural structures connected. So, for example, some of our questions were: where is the building? In what year was the building built? In which context is the building located? Are the bells in a church or in a civilian buildings? Which is the mounting system of the bell, and so on. And next, please. To build a first set of relations, we identified in the database a set of architectures which were already described in the catalog through the CJEC web cataloging system, which is the software we use for the input of data, and made a match with some of the previously cataloged bells. And second, we analyzed how to catalog the bells, deciding to experiment the application of a different descriptive model. So we didn't use the artistic property descriptive model, but instead we applied the musical instruments format, collecting a minimal set of data related to acoustic component, like, for example, the nominal note, the main note of each bell. We paid particular attention to the connection between the polyorganic instrument, represented by the whole set of bells, and the individual bells that compose it. And so we described the instrument, the musical instrument, as a complex instrument, using a high-level card for the set of bell. In Italy we call the bell concert, because it makes the idea of the sound together, all the bells make a concert, and a certain number of low-level cards, one for each bell within the concert. And during the cataloging process, we collected and attached the sound recordings to the individual bell cards with the nota di battuta, the main note for each bell. So in this way, we aimed to create an initial core of objects, description, and the relations around which we are continuing to create new modules that we are implementing. This includes work on authority records for the historical foundries, and expanding the collection of description of new audiovisual documentation, and retrieving historical documentation from parish archives or foundries. Next, please. And the data collected are part of a knowledge graph based on Polifonia Bells ontology, which is fully integrated as the organ ontology and the meetups one in the broader ontology of the project, the Polifonia Ontology Network. And in this way, we can facilitate the establishment of increasingly broader connections between elements and make them accessible through the web by publishing them as linked open data. Next, please. And the data set we produced is available on the Ministry of Culture's Open Data portal, and is also on GitHub, and it can be queried through Sparkle Endpoint, Virtuoso Sparkle Endpoint we use by anyone who is willing to develop an application, portal, website. Next, please. I think there is something else on, yes, on the Open Data portal of the ministry, and or who wishes to query sound objects also for creative reuse. I will just mention a couple of examples of visualization we developed. Next, please. The first one is the one of the general catalog of cultural heritage, which I will show you in a couple of minutes from the website. And here we can visualize the relation between instrument, architectures, location, and listen to the notes we collected. And next, please. And another interface we are developing in-house is more focused on geographic features, acoustic characteristics, and technical aspects like the nominal note. In both cases, we have the link with the RDF data and on the linked open data on the Open Data portal of the ministry. I think we can stop sharing the slide, so I will show you very quickly. Okay, I try to, sorry. Okay. Maybe you see the interface of the catalog, and sorry, just a moment. Okay, and from the main interface of the catalog, we can select the facet concerning musical instruments. You see, we have also a lot of organs. And if, for example, we search for a set of bell, in Italian is concerto di campane, sorry. We have all the results of the catalogation. We can select one. And from here, we can reach, we see all the concert was made by two foundries, for example, Borrell e Dadda and Fondoria Capanni, and we can reach all the bells which were made by this foundry, for example, or, for example, selecting the church, in this case is Chiesa di San Marziano, we can reach the bell concert, so all the bells which are in the church. And if we open the card of one bell, we have a preview with a certain number of details, for example, the measurements. This is the mounting system, a falling clapper, the foundry of this bell, because you can have a set of bells in which 3 bells are made by one foundry and the other from another foundry. The address, of course, of the church, but here you can listen. I hope you can. I don't know if it's working. Okay, of the nominal note, which is very important because it's like an ID card of the bells, because it's every bell with the same measurements, same material, a different sound, different note. I mean, the sound maybe is the same, but if you have the spectrum of the acoustic characteristic, are very, very typical of each bell. I show you very, very quickly the other application we are developing. And here you have a map, and you can select one set of bells from the map, and then you can play. So from here, all the bells. And then you can go through the catalog or directly to the RDF data on the open data portal of the ministry. Okay, that's all. Thank you.
Thanks so much, Elena. There might be some questions for you if you can go to the chat.
21. Okay, I hope I can answer, but if there are very technical questions, we can I just can forward them to. Sorry, I'm trying to see where they start. Which is the first, Marlo? Sorry, because.
Let me see. There's been some talking in the chat, including myself.
I see a question. Were you able to control for environment regarding the bells? What was the process? Okay, that was quite critical. It's very important, but we just had some standard with an expert recording the bells, but we didn't have a complete control of the environment. So the sound, it's not, I think, pure, but it's quite difficult to have a clear recording, a process of recording of the bells. We made this process with musicologist, who is also a bell ringer, and so he had all these technical instruments, equipment, professional technical equipment, but we didn't make a very high-level professional recording in this file. Do you plan to organize workshops or longer presentation? This is a general question, so I think Marlos can answer. And is the organ data connected to other Polifonia data? Okay, Peter answered. I think that's all. You also have. Okay, thank you. This is also nice to have the environment. Thank you.
Yes, thank you so much, Elena, and all the other speakers, and especially everyone else in this webinar, all the listeners and the audience and the questions. I think we made it exactly in time. I mean, we had to end at 16:15, so we were right in time. I realized that we have not been able to answer all the questions, and that we have sent a lot of links and you know, to explore. Maybe a little bit too much. I want to add one more to that, because I think has been a lot of information. We do have a YouTube channel with more tutorials and videos to make sense of everything. I think it's wise if we would send some email after with a little bit more information and maybe an overview of the links, and maybe we can still get back to some of the questions that we were not able to answer. And oh, there's one. What are the next steps for the project? That's a good one. I can safely say, but maybe the pilot leaders can do this better, that some pilots have follow-up projects and follow-up funding. But the Polifonia project formally ended late April. So the consortium has now been disbanded, actually, and everyone is going their own way. But we are, I mean, I think I can speak for everyone. We are very into collaborations with other partners. And so don't hesitate to get in touch with us or with specific pilot leaders if you are interested. I see that Andrea is raising a finger.
Andrea is trying to say something. I'm coughing. This is why I was so silent. As many of the projects, Helmut, we of course are kind of faced with a temporary funding, but Polifonia put a lot of thinking also to how to go about the sustainability, and has achieved the participation of cultural heritage institutions, which hopefully will continue to exist. So you heard the presentation about the Bell pilot and the integration into the Italian big catalog, which I think is a big plus. I'm coming from a data institute in the Netherlands, and we are looking into turning some of the experiences into teaching materials in the environment of our usual data research data management kind of expertise trajectories. So as Marlu said, I think we are still open to being reached out to and having emails. And I think the partners also individually are also eager to looking for new funding sources and engaging in a new kind of recombined collaborations with also new partners. And the University of Bologna has also committed itself to maintaining the server structure, which is actually important to provide the access to the API access to all the knowledge graphs and to host the portal. So there's a big commitment from the University of Bologna. And the principal investigator, Valentina Precciuti.
Okay, thank you, Andrea. I think we should wrap up now, unless the other speakers still have something to add. See some shaking heads, so no. I think then Andrea has put some nice final words to this. Thanks so much, everyone, for keeping your attention and listening to all these details and information. I really hope that you are inspired to get into the ecosystem website and the other platforms that we have to sort of like further explore this amazing project. And hope to see you again all soon.
Thank you.
Bye. Have a good afternoon.
Thank you.